Okay, so happy Monday, everybody. Thank you for those of you who've come to class, and for those of you who are watching the video later, thanks for watching. I just kind of wanted to take a little bit of time before I get started on the lecture material to kind of check in with you guys as students to kind of just get a feel for how you guys are feeling, maybe about, in particular about this class. And my intent is that no one is kind of stressing or freaking out about this class. I've tried to keep, I don't know, the workload reasonable and manageable, but still at least cover the content covered in lecture. I will post homework assignment 5 later this week in the next couple of days. So be on the lookout for that on CCLE. And I know we're a little bit behind on getting homeworks 3 and 4 graded, but we will get those graded, and you can get a better sense there. The data camp homework is intended to be kind of easy points as far as getting those in, and the lecture view quizzes are also intended to be fairly easy point kind of grade boosters. And so the only thing kind of left will be the final exam, and I'll try to give you a good idea of what to expect for the final, and hopefully that will also feel fairly straightforward. But definitely you should practice. So come week 10-ish, towards the end of week 9, week 10. I'll give you kind of a descriptor of what you can expect, and hopefully you can practice just writing some things, and practice kind of working with data and making pictures and stuff to do that. But I don't know. I don't know if anybody wanted to say anything, if they have any concerns or worries about this class in particular. Okay. Well, if you got anything, don't hesitate to share anything. Yeah, I hope. I don't know how your other classes are going. I hope it's going okay, and yeah, we'll keep going on here as far as lecture content goes, and yeah, so we've been talking about object-oriented programming stuff, and so there are actually a few more object-oriented programming methods that I wanted to cover today to kind of expand on some of the classes that we've been looking at. Just because when you implement these special methods, Python is able to kind of handle your class like other Python objects that we're familiar with. So so far, what we've been dealing with is the card class, okay, and the deck and the hand. And what we said was, we're looking at a deck of cards, and as far as the deck of cards go, the card has a suit and it has a rank. And so when you create the kind of the initialize method, which is going to assign a numeric value to the suit, a numeric value to the rank. And then we created a couple methods. We have the string method, which is used when you call print, and it's going to print out the object in a kind of a user-friendly form. It'll say something like the ace of spades or the 2 of clubs or something like that, okay? We also have the LT and EQ, which is used for comparison. So you can implement less than and equal to kind of see if 2 cards, if you can compare 2 cards, or you can test if 2 cards are equal. And you can, all of this is actually called part of the Python data model. And there's other methods. There's a greater than, and there's a not equal, and there's, different kinds of things. They kind of get implemented, like if you have less than, you probably don't need to do a greater than, but you can have a separate greater than thing, and it will use that method. But But a lot of these things, once you do it, it will allow you to do things that, but the less than is very important because it then allows you to sort your objects, right? Because there's some kind of way to rank these or compare these and you can sort them. So this is how we've defined our card class. And, we have these two kind of lists inside here, and we use that for when we want to print out the definition of the card, or print out the card in string form. Okay, so we have this string, is that less than equal? Okay, and then we've created a deck class, and a deck is basically another class. The initialize method will generate 52 cards and store them all in a list called self.cards. Okay, and then the string method will kind of iterate through all of the items in self card and print them out. And then we've got a few methods: pop card, add card, shuffle, and sort, and move cards, which allows us to kind of transfer cards from one deck to another deck or to a hand or something like that. Okay, and the shuffle uses random.shuffle, and so we have to make sure we import the random module into Python here. Okay, so this is kind of what our deck class looks like. And when we initialize, we create an empty list, and then we create a bunch of card objects. Okay, we create 52 of them, and we store all of those card objects into self.cards. Okay, and then we have these other methods, ways to represent the string. We have a way to kind of pop a card or deal a card from the end of the deck. We can append cards. We can shuffle the cards, which we use as random.shuffle. We can call sort, and we can call move. Move cards, which calls from the self to an other or a hand, and we add those cards there. Okay. All right, and then the hand card inherits from the deck class, so it learns all of the same methods from the deck. Okay, but what we've done is we've modified how the hand gets initialized, and when we initialize a hand, it's going to start off empty, and then we also give the hand some kind of label, and we can deal with that there. Okay. All right, and so here's just kind of an example of how our objects work so far. So we're going to create a deck by calling our deck class. We're going to create a hand by calling our hand class, and we give it the label new hand. And what we're going to do is we're going to move 5 cards from the deck to the hand. And when we do that, we can print out the hand, and we get basically the 5 cards at the end of the deck. So again, when we initialize deck, it creates it in kind of new deck order, starting with the ace of clubs, and it puts all of ace through king in clubs, then ace through king of diamonds, ace through king of hearts, ace through king of spades. And we're taking the 5 cards at the end, which will be the 9, 10, jack, queen, and king of spades, and those get put into our hand. So this is what our hand has, and that's where we are right now. Okay. One thing that happens though is the way our cards are represented. If we create a card, if I create a new card here, we have a way to print out the cards. We can say print card 1. So card 1 is just a new card, and it comes out as 2 of clubs. But if I just type card 1 here, this is how it gets shown on the screen. It shows, you've got a card object at this memory location. Okay, card object at this memory location. And this is basically completely unintelligible. You have no idea what this is. Okay, here, if I do the same thing with card 2, which was created using card 3, 11, and that's the jack of spades. Print card 2 is the jack of spades. But if we ask, what is card 2? Card 2 gets printed out here, and it says basically you have a card object at this memory location. Okay, and again, this is not very helpful for us. So, and then it's even worse, here if I say, take the, let's make a new hand here, okay? And let's move 5 cards from the deck into the hands. I think this is gonna be like the 3 through the 8, or the 4 through 8 of spades or something like that, I think. I'm not sure, but I have no idea, okay? It's, it's showing up here, and this is, basically I have a list of card objects, but I have no idea what these things even are, right? So this is totally unintelligible. We can't make any sense out of this. So to help us, we can create something called, we can use the method called rep for representation, the repper, okay? The dunder method repper or representation is used to show the official representation of the card object, okay? And so the output of repper should be the command that is used to create the card object. So back here, when we created the jack of spades, the way we called it was calling card 3,11, card 3,11. So when we do that, when we ask for the representation, we want it to say card 3,11. Basically, the call that was used to create this object should be the representation of the object, okay? So here I'm going to redefine my card class, okay? And I could have used this form using kind of %s of, card %s comma %s, and then paired it with, self.suit, self.rank. Here I kind of used the string pasting using pluses here. And so I have card plus, because the way we create the card is we put in the suit and the rank, right? So we're going to do card self.suit, comma, space, self.rank, expressed as a string, okay? So this gets added to our class definition of card. Okay, and so now that I've done that, okay, just to show you a comparison, card 2, which again was created earlier, way back here, card 2 is created back here under the old definition. Card 2, when we ask, what does it look like? If we just put in the name card 2 here, it's going to come back as this, card class object located at this location in memory, okay? When because we have the string representation method, it says it's the jack of spades, okay? Here, I'm going to create a card 3, which is created using card 3,11. And now card 3, because I've got the representation method, this thing, because I have this, it now outputs as card 3,11. Sorry. Card 3,11. And so this, when I print it out, it still has the same string representation. It's still using this when we call print on it. And so this gets represented with jack of spades. But card 3, this comparison, compare this output versus this output, this we can actually make sense of, okay? Because we can say, oh, this is going to be the third suit, which, maybe is not clear to the user just yet, but the third suit is spades, okay? Or I guess the index 3 suit is spades, right? Because it goes clubs, diamonds, hearts, spades. So this will be spades, and then the 11th rank card, which will be the jack, okay? And so we can say, is card 3 equal to card 2? This still uses the equality feature here, and those are equal, okay? So that's true. But the key part here is that this gets represented this way, okay? And so when you change the definition of a class, and you have other classes that contain or inherit from those classes, you have to redefine them. So here we have to redefine the deck class. We have to redefine the hand class, just because when here we're talking about card, the old definition of deck uses the old definition of card. So I have to redefine deck so it uses the new definition of the card class. Okay. All right, and so once I do that, and I call, and I say move cards to the hand, okay? Now I can say print out the hand, and we get the string representation, which is easy to read, okay? And hand.cards, okay, when we ask directly for that list, okay, it's not super easy, okay? It's not as easy to read as this, but this is a lot more intelligible, I believe, in my opinion, a lot more intelligible because it at least gives us a sense of what values it contains. It's a lot more intelligible than, say, this representation, right? So when it's like this, you have no idea what this is, okay? And at least over here, we can say, oh, okay, we can see at least the numbers associated with the suit and the numbers associated with the rank, okay? And this would be, how would you create the calls that would be needed to create these cards here? Is that good? Does that kind of make sense as far as this representation method? So that it's a useful thing to implement. Okay, let me go ahead and give you your first view quiz answer for today. Today's first view quiz answer is D, D as in dog. D as in dog is your first view quiz answer. Okay, so sometimes, we want to, we have questions and we want to ask things like, how many cards are in the deck or the hand? Okay. And, we can get these answers by asking, accessing the value directly inside the method, right? So right now, the way our deck class is implemented is that we have a list inside deck called deck.cards, and that list contains card objects, okay? Now we could ask for the length of that list inside the deck or inside the hand. But when you create classes and objects, you want to kind of use the idea of encapsulation, meaning you're going to interact with the object rather than the objects inside the object. So rather than dealing, working directly with, say, the card list inside the object, you want to kind of be able to work directly with the object. So if we take our hand, this is how our hand is defined, which has 5 cards in it. Okay. And if I ask, what's the length of the hand, it's going to come back and say, hand, object of type hand has no length. Okay. Now, if I say, what are the variables inside hand? It says you got 2 variables. You have cards and you have label. And then you can say, okay, well, hand.cards is a list. Okay, it's this list with 5 things in there, and we can ask for the length of that list. Okay, but this violates the notion of encapsulation, where we don't, when we create objects, we want to work with the object, not the stuff inside the object. Okay, so we want to kind of interact with the object rather than having to kind of dig into what's contained in there. So here we're going to say what we can do is we can implement the special method double under length. Okay, double under len, which is going to which here we're going to use to define as, let's return the length of the cards list. Okay, and so we're going to say anytime somebody asks for the length of a hand or a deck class object, what it should return, okay, rather than telling us that there's no length, okay, we're going to say what it's going to do is it's going to look at self.cards and return the length. Okay, so again, we're just kind of making our deck class definition even bigger. Okay, so our deck class, we have an initialized string, and now we've added this definition here. Okay, and so the length here is going to be it's going to return the length of self.cards, whatever list this is. Okay, and then again we have to, because hand inherits from deck, we have to redefine our hand class to use the new definition of deck. Okay, and so now I can say, all right, create a new deck. And I can immediately ask, what's the length of my deck? And it says, okay, there's 52 cards. We can create a new hand and move 5 cards from the deck to the hand. And we can say, all right, what's the length of the hand? The hand now has 5 cards. What's the length of the deck? The deck is now down to 47 cards. Okay, so these things are implemented. And again, this is much preferred rather than calling accessing the object directly, you know, deck.cards or something like that. Okay, that's just kind of object-oriented programming kind of best practices there. Okay. What if you wanted to take your deck class and do something like slice it? Let's say you want to get like the first 5 cards out of the deck. Okay. Right now, we don't have a way to do that. Okay. So if I say take the deck and slice from object 0 to 5, it says deck object is not subscriptable. Okay. What if we want to iterate through it, right? So our deck has 52 cards in it, or 47 cards in it, whatever it has, and we say, you know, let's iterate for each card in the deck. Well, can we print out the card? It's going to come back and it's going to say the deck object is not iterable. Okay, so our deck is not iterable. Okay, what if we wanted to kind of sort the deck, right? If we wanted to call sorted on the hand or something like that, and it comes back, and when you do sorted, it comes back and it says it's not iterable. Okay, so what can we do here? Okay, so all of those behaviors of slicing and iterating and getting a sorted version, those are all going to be enabled if you implement this method called getItem. Okay, getItem allows you to kind of interact directly using kind of the ideas of slicing and iteration here. Okay, and so so all we have to do is we just implement this thing, right? And the way you implement this, okay, so well, first of all, I should point you to the reference. Okay, so if you open up the reference, there's a whole bunch of stuff on the data model. There's lots of things. It's a lot to read through, but a lot of these things we can emulate what's called a container type, emulating container types. Okay, and so length is actually one of those things, and then getItem. So getItem self comma key is going to implement some version of self accessing the key. All right, so what we want to do is say, well, somebody asks, you know, deck with a certain key, what's it going to do? Well, what we want is we want to get back the card located at that position. So if somebody says, you know, give me deck square bracket 0, we want the top card. We want the first card there, the card located in position 0. Okay, or if somebody says deck square bracket 52, we want to be able to get the card in the 52nd position. So all we're going to do is we're going to say, all right, from the cards, deck.cards, we want to pull out whatever is in that particular position here. Okay, so we're going to call key the position, and we're going to return the card located at that position inside the list self.cards. Okay, so getItem gets added to our ever-growing class definition for deck. Okay, so now deck has a few special methods. We have the init, we have the string, we have length, and now we have getItem. Okay, and so here I redefine my deck class with this new method, and I'm going to create a brand new deck. Okay, so I create a brand new deck, and we're going to start off with Ace of Clubs through King of Clubs, Ace of Diamonds through King of Diamonds, etc., etc. Okay, and so now I can slice. I can take the deck and I can slice it. I can say, give me cards 0 through 8, all right? And it gives me back basically the list with all of those cards. It uses the representation, okay? And so we're gonna get card 0, 1, okay? So it's gonna use this. Now, I could have, back here when I did, when I defined the representation of the card, where did it go? Back when we gave the representation of the cards here, we could have used the same thing and it would have been a lot easier to read. Okay, we could have, it's not recommended, but it's not going to break Python. Okay, like Python would allow you to return a string that looks like this, okay? However, the recommended practice is that the representation be the method used to kind of create that object, okay? So anyway, when I slice it, this is what I get, okay? This is what I get. And this is the representation. Now what we want, maybe we want it to print out in the way we like, okay? So now that I've created this thing, now that I've created the deck using with a get item method defined in it, my deck is now iterable, okay? And all subsets of it is also iterable, okay? So now I can actually do for item or card or whatever in deck 0 through 8, and it's gonna iterate through this, and we can say for item in deck 0 through 8, 0:8, print the item, and it's going to iterate through that and print out what we have here. Ace of clubs, 2 of clubs, 3 of clubs, up through the 8 of clubs, okay? And so this is iterable, and I think that's just really cool. In that this is just some loosey-goosey class definition that we're kind of creating along the way. And just the fact that I've implemented this thing get item, my class is now subsettable, or like I can slice it and I can iterate through it. And if you can iterate through it, you can also run things like, getting sorted and stuff like that, okay? So just another example, all of the rules that apply to kind of basic slicing. So here, this is basically start at the 12th object, colon, nothing means go all the way to the end. And then another colon means the step size is 13, right? So 12 : 13 means start at the 12th object, go to the end, and take a step size of 13. And here we get back these 4 cards. And if I say print those out, this is going to basically pull out all of the kings in the deck, because the kings are all, separated by 13 cards. So we got king of clubs, king of diamonds, king of hearts, and king of spades put in their kind of suit order there. Okay. So, get item is, I think, such a cool kind of dunder method that really enhances any kind of object class that you're going to be defining. Okay. If I redefine my hand, okay, I can call shuffle and shuffle that up, and we can move 5 cards into the hand, okay? And now that I have get item implemented, we can also call this function sorted, okay? Whereas before we were not able to call sorted, it gave us an error that says this thing is not iterable, right? So if I say, if I ask for sorted, it says the hand object is not iterable. And now, now I can sort it, okay? And it puts it in order from least, in suit order from least to greatest, clubs, then hearts, then spades. Or we can just, and again, sorted does not affect the version of hand itself, right? So you have an internal method called sort, which is going to sort the object itself. And then you can also ask for sorted, which is going to give you back a sorted view of the object, but not, or sorted copy of the object, but not actually sort the object itself. So we got, so here it is in order, suit order, and here it is how it actually stands, left unchanged. The other special method that kind of goes with get item is set item, okay? Now, set item allows you to kind of alter values inside whatever class you have. So, if you're dealing with something like, say, you have a class that's going to be used for like tracking a bank account or something like that, you can use set item to change the values inside there, okay? And so here we're going to say, as far as setting an item here, the key that what we're going to do is we're going to say we want to set a card in a certain position. Okay, so the method for set item is self comma key comma value, right? So if you look at the definition for set item, self key value. Okay, and it's going to basically implement assignment to self key. So what happens when you do self key? Right, and we're going to say, assign the value to self key. So in our case, we're going to say, what, don't just do self.key, we're going to do self.cards key, okay, because this is basically the list where we store all of our cards, and the values will be the cards itself. And so when you do that, that's going to allow functions like random.shuffle to actually rearrange the objects inside a container, okay? And so right now, in our class definition, we had a method called shuffle that we would call using deck.shuffle, okay? But this is actually unnecessary. It's unnecessary to use this if you instead use set item, okay? And I would say using set item is generally preferable to having a method like this, okay? I mean, there's nothing wrong with this per se, but using set item, using a dunder method is probably preferable here, okay? So what we're gonna do, the difference here is, back when, under the old definition, the way we would shuffle our deck is we would do deck.shuffle. That's fine, okay? Deck.shuffle, the way it worked was it would call .shuffle self, and it would run random.shuffle self.cards, okay? Here we're going to use set item, okay? We implement the dunder method set item, so double under set item self key value, and we're going to say take whatever value you have and put it inside cards key, and it's used in conjunction with kind of get item there, okay? And so here I'm going to create a brand new deck, all right? And if we look at the brand new deck comes in new deck order, right? It starts with the clubs, goes to ace through king, then goes to the diamonds, ace through king. So this is kind of the first 10 cards in the deck, okay? And now I can call random.shuffle, which is just your kind of standard shuffle function that's part of the Python random module. So we can do random.shuffle and pass it the deck object, okay? And if I tried to do this without set item, this thing would fail, okay? This would actually, and I didn't have an example of this, but if I tried to do this without set item, this would cause an error, all right? So I do this shuffles the deck, okay? And again, random.shuffle, when you run it, you don't actually see any instant change here. But we can ask, well, same thing, let's print out the top 10 cards of the deck. And now that I've called random.shuffle on this, we can see that now we have a bunch of different cards. It's been scrambled. It goes 9 of diamonds, 5 of spades, ace of clubs, king of hearts, okay? So we can call shuffle, random.shuffle on the deck, rather than using the kind of the method deck.shuffle, right? And so this is made possible by calling set item, right? And this also allows us, if I wanted to, and I didn't do an example of this, I could say, deck position 5, we want to put in this card. Okay, we want to insert this card into this, or I guess not insert, but just replace whatever card is there with another card. Okay, and that, if you're not careful, it's based, you can end up kind of messing up your deck, so you don't have 52 cards, or I mean, so you might have duplicates of cards and things like that. But it allows you to kind of set values within the class. Okay, are there any questions there? Does this kind of make sense as far as some of the special methods? And so if you're ever going to kind of create your own classes, you definitely want to familiarize yourself with this section of the documentation and the data model documentation, and there's a bunch of stuff. We saw some of these things, such as emulating numeric types, where you can do add, subtract things like that when we were talking about the time object, because we wanted to be able to add time objects and things like that. And so, so those things are implemented using the emulating numeric types. As far as our deck and our hand, which contains other objects, we want to emulate a container type to allow it. Right, thanks here. Okay, we have a question that says the set item replaces a card it doesn't insert and move everything over. Right, the set item is basically like you can think of it as if this were a list, right? If you had a list and you say list key 4, okay, equals 10, it's going to take the value 10 and just put it into the index 4 position in the list. Okay, it's just going to replace whatever's there with a new thing, right? So if you wanted to kind of don't think, well, let me see. So I have I'm just kind of messing around here. I don't, so here, let's just see. So here, let's print our deck. Okay, so this is what we have here. All right, so let's do deck position 0 equals card. Let's do a 0, 1. So this will be here, and then let's just do, let's print out the deck. Okay, yeah, it puts the ace of clubs right here. And so just wiped out 9 of diamonds and it put in, so 9 of diamonds just got replaced with ace of clubs. Okay. I don't know if I can just do deck.append. Let's see, card. So the last card right now is the 4 of spades. Let's try putting in another ace of spades here. Yeah, I can't do a deck.append. Okay, so I don't think I can do this either. Deck.insert has no attribute insert, yeah. So you can't just do stuff like that, okay? All right. Let me go ahead and give you your second view quiz answer. Did I already do that? No, okay, all right. Second view quiz answer is A as an apple. A as an apple. Oh, is it already 5:40? Okay, all right, 10 minutes. Well, I'll cover a couple of these Python features and I'll probably run out of time and we'll have to continue some of these Python features at our next lecture. Okay, A is your second view quiz answer. Okay, so so Python has a bunch of kind of like nice little features that aren't necessary as far as like, you know, you can write your programming without having any awareness of some of this stuff, okay? But these are really nice, okay? So one thing is you can run an expression, a conditional expression directly in kind of like one line here, rather than setting up an if-else type of statement, right? So for example, we could say, you know, what's the log of some number, right? And right now, if you can say, you know, if you give me a negative number and you put it into math.log, well, actually, let me just show you what happens if I didn't write this conditional statement. If I say x is equal to -3, and I say math.log of x, okay, I get a value error, right? So this right now, this error's out. Python says you can't take the ln of -3. Okay, so what you can do is you can write this statement: if x is greater than 0, calculate the log. Otherwise, set it equal to nan. Okay, and this, you know, this will avoid some kind of math error here, right? What you can do is you can just write this right here. You can say y equals math.log of x if x is greater than 0, else the value it should be assigned is float nan. Okay, so this is kind of an if-else statement, but just in one line. So rather than having to write it this way, you can write it, a little bit more efficiently in one line here. Okay, and so here, if you say, well, what's the log of e? You get 1. And again, here, if I do x is -5, and I write the same statement here, it comes back as nan. Okay, so it's a nice little thing. Okay, it's kind of like the if-else statement in R, except it's just written in the line here. Okay, so another thing is like you can take a recursive expression and turn it into a conditional expression. All right, so here we could define the factorial function as saying, as this recursive thing, okay, where you have the base case where n equals 0, return 1, and otherwise, work recursively where you're going to take the current value n and then multiply it by factorial of n minus 1. So this is going to, the first time you run it with 5, and it's going to do 5 times whatever factorial of 4 is, and it works recursively until it gets to 0, and then it multiplies all those together and you get 120. Okay, here, this might be a tiny bit harder to read, but again, this is just, you've got a base case, right? So we're going to say return 1 if n is equal to 0, otherwise return this. Okay, so this works. I don't know if this is more readable, so probably a regular person can read this very easily. When they read this, it might be a little bit more confusing, so it might not be beneficial in this case, but you can include these conditional expressions inside some kind of function definition and things like that, and it could even work in a recursive sense there. Okay, I think we've already seen this, but you have you have star args and you have star quargs, which kind of work with these variable word arguments, right? So we saw this when we were working with tuples, but you can basically say, have a function that's going to print everything here, and it's going to accept a variable amount of arguments. So normally Python requires, positional arguments, and if you got 5 arguments listed in your function, it expects to see 5, and if you give it fewer than that, it might complain if you don't have default values. If you give it too many, it's going to complain that it's got too many of these values. So here we can do star args, and it's going to kind of gather them all into a tuple and iterate through them. Okay. Here we're going to kind of take this. I have star dice, okay? And so right now I just give it, the first example, I give it 1. And basically what this is gonna do is it's going to kind of just, it's going to iterate through all kind of instances of our dice, right? So what it's gonna do here, just to kind of show you, first I have just roll 20, but I can also do roll 6, 6, 20 and things like this. And this is kind of the idea of, like, if you have a 20-sided die, what number do you get, okay? And so with a single 20-sided die, it's just going to go through the first item, which here is just the number 20, give me a random integer, one random integer from the die, and then add that to whatever total is. So it prints out what it rolled, a 12, and it gives us the total is 12, okay? Here, I can give it a kind of a multiple values here, 6, 6, 20, and all 3 of those values, 6, 6, 20, get gathered into a tuple here. And so first is going to run through the first die, which is 6, and it's going to print out whatever roll you get. Then it does it for the second roll, and which is a 6 here, and it prints out the roll, adds that to the total, and then does it for a 20-sided die. Okay, so it goes 6, 6, 20, and the first 6 rolled a 3, then we rolled a 4, and on the 20-sided die we rolled an 8, and that sum is going to be 15. here we rolled the 2 6-sided die and a 20-sided die, and we get a roll here. And then, we've just been kind of getting bad rolls here, but the first 2 6-sided die rolled a 3, the 20-sided die rolls an 8, not great, and the 20-sided die rolls a 3, also not great. And the total here ends up being 17. Okay, but we're allowed to pass it arguments of differing lengths, and the function handles it, right? Because it gathers everything up into a tuple. Okay, and similarly, you can run star quargs, which will gather everything into some kind of keyword arguments, all right? And so here we can take, this allows us to pass basically an arbitrary key and an arbitrary value, right? So a lot of times when you call some kind of argument or some kind of function, it's expecting certain arguments. And in this case, those arguments aren't defined. And so we're just doing arbitrary keys here and arbitrary values. And it's going to kind of gather those together in a dictionary, basically. And it can iterate through the dictionary items. So we got CA equal to California. And it's going to say key California has value California. Key OH has value Ohio. And again, these could be variable length. So one thing we can do is you can take 2 lists of the same length and you can zip them together into and throw it into a dictionary. And so now we have a dictionary here. And if I were to pass this into this as directly as a dictionary, it's not going to work. Okay, so even though it says star quargs here, it doesn't know what to do if you just pass it a single object, which is a dictionary. Okay, what you have to do is you do star on the dictionary. Star on the dictionary is going to scatter the dictionary contents into something that looks like this. Okay, it's going to scatter the dictionary contents, and then it can iterate through all of this. Okay, I guess I messed up that one slide there. And I guess similarly, if you wanted to do something in matplotlib where you had multiple kind of settings, such as you want the color to be equal to blue, the line type equal to 2, and the line width equal to 3, you can gather all of those together into a single dictionary, and you can pass those into whatever matplotlib function that you're plotting to get them all to go. Okay, we'll have to cover list comprehensions on Wednesday. List comprehensions are quite cool. So on Wednesday's lecture, we'll look at list comprehensions, dictionary comprehensions, and other kind of neat little features. But it seems like we've run out of time for today. Let me go ahead and give you your last view quiz answer. Last view quiz answer today is the letter C. The letter C as in cat. C as in cat will be our last view quiz answer. Okay, we'll end there for today. You can expect to see, homework 5 posted in the coming days. As far as data camp goes, you just have to earn your 2000 XP by the end of the week. And after this week, you'll just see another kind of 2000 XP assignment show up. So right now, I think if you do your 2000 XP assignment, it's going to count. There's 3 2000 XP assignments, and you'll get credit for all 3 of them. So so that was a little bit of a mistake in my creation of those assignments. But so I'll just create a new one next week, and I hope that's fine. Okay, have a good night, you guys, and we will see you guys on Wednesday.